Hey engineers, this is Mr. Hernandez, and in this video we're going to be going over a new unit. We're going to be starting to talk about energy, specifically solar power. So we're going to start off with a presentation, so make sure that you have a notebook out and something to write with, because you will have a quiz based on this information, and we're going to be continuing to use it for the next couple of lessons. So without further ado, let's go ahead and take a look at the presentation. So like I said, this is going to be solar power. So go ahead and start with that title, and then let's jump in to the next slide. Starting off big picture here, so energy production. So we need reliable energy sources to keep our modern world moving. We use energy and electricity for all kinds of things, from light to heat to cooling, communication, powering our phones and computers, transportation, not just talking about electric cars. Energy is kind of big picture, and it includes all the things that we use for energy. So when I talk about energy here, I mean electric cars with that electrical energy, but I also mean the energy stored in the gasoline you put into a conventional car. And then also cooking. Again, either electric stoves or the gas that burns in the burners to heat things up. Now, energy comes in a lot of different forms. So as engineers, our challenge is to capture that energy and make it useful. So either by getting it to where it needs to be, like the gas coming out of the stove to heat your food up, or by turning it into electricity, where controlling it is as easy as hitting a switch. So there's a lot of different potential sources of electricity. So let's go ahead and split those up into a couple big categories here. So the first big category is non-renewable energy. So this is energy that comes from sources that get used up faster than they can be restored. So the big examples are oil, coal, and natural gas. These are all called fossil fuels, which means that they're sources of energy that come from things that died millions of years ago. So basically, they're found in underground storage systems. We can dig them up and use them. And the thing is, it takes millions of years to restore them. So at the rate that we're using them up faster than they can possibly be restored, and that's why we call them non-renewable. There's two others here that are a little bit different. So biomass means burning natural things. So things like trees or plant waste. Curious because if you chop down the whole forest and burn it up for energy, that's not renewable. But if you just take all the branches that fall off and burn those, then that is renewable. So biomass can be either one. And then last is nuclear. I'm putting nuclear here as non-renewable because we can't get any more of those materials, but they last a super, super long time. So it's non-renewable, but we're probably not gonna run out anytime soon. It's a interesting in between. What's important here is that these are energy sources that can be used up and potentially run out. So moving on to the next one, we have the opposite. We have renewable energy. So this is energy or electricity produced from sources that either don't get used up or naturally come back in a short period of time. So examples of things that don't really get used up include solar, wind, hydroelectric, geothermal, and tidal. These are all things that basically capture energy from things that were happening anyway. The sun's gonna shine no matter what we do, but if we put up certain devices, we can capture the energy from the sun. Same with the wind. The wind's blowing anyway. If you put up a wind turbine, well, the wind was already there. You're not taking the wind away. We're just turning some of it into electricity. I have biomass here again because, like I mentioned on the last slide, done responsibly, biomass can be renewable, but there's no guarantee that it is. The important thing here is that these are all resources that don't get used up. Most of them don't emit any kind of carbon dioxide, which contributes to greenhouse gases and global warming. But that doesn't mean that they're perfect. Most of these rely on natural things happening. So there are issues like, what happens when the sun goes down? What happens when the wind stops blowing? How do you get electricity then? Now that said, we're gonna go ahead and focus on solar power here. So let's take a closer look at that. So what is solar? Well, it's written right there. Solar energy is refers to systems that capture energy from the sun's rays, and it makes that energy from the sun useful to do other things. Now, there's three big categories here. All of these have different subcategories, but these are the three major ones. So the first is thermal energy or thermal solar energy. The second one is photovoltaic or solar PV. And the last is concentrated solar power. So let's go ahead and look at those three, starting with thermal. So solar thermal systems are going to be the simplest ones, and that's why they're the oldest ones as well. So solar thermal technology uses the sun to heat things up directly. So it's not what we think about with solar energy, where we're using the sun to make electricity. Instead, you're using the sun to just make heat and just collect heat. So solar cooking would be one example, and also solar water heating is actually relatively common. These look about how you would expect. We have these reflective surfaces to collect the sun's energy and focus it in one spot, and that one spot is going to be heated up. So if you put food in that pot right here in the center, then you can heat it up using nothing but the sun's rays. Doesn't mean you have to cook dinner before the sun goes down though. So there's a slight problem right there. The next example is solar heating or solar water heating. This one's very, very simple. It's just a series of black pipes that are exposed to the sun. So just like on a hot day, if you turn on a water hose, you might have experienced that the water is warmed for the first few seconds as all that hot water flows out of the hose. It's the same idea, except on purpose. So you expose these black pipes to the sun heats up the water inside, and then when you need hot water, you're using the water from there. You can see these systems have these tanks up here to store the hot water. So it's basically like, it's basically used to heat up water for things like showering and bathing, things like that. It potentially more efficiently than having a water heater as well. So this is a really interesting and very low-tech solution, but it's also not really what we think about when we think about solar. So this is sort of a smaller chunk of the puzzle here. The next type is photovoltaic. So photovoltaic or solar PV uses special materials that make electricity when exposed to bright light. So if you lay these materials out into the big sheets and expose them to the sun, you can generate lots of electricity. This is really the typical example we think of when we think of solar, these fields and fields covered in these solar panels, or you see them on rooftops sometimes as well. So this is the main way that we produce electricity with sunlight. Now these are also really, really effective, especially if you can get them into brighter and brighter light, and that's why we use them on spaceships. So the International Space Station up above our heads, it uses these, they almost look like wings of solar panels in order to generate electricity. You can imagine in space, there's not a lot of other options. You can't really use like hydroelectric because there's no rivers in space. You don't really want to burn anything like gasoline because there's no oxygen. And so solar panels are very, very effective in space especially. All right. Let's move on to the last category, which is called concentrated solar power. So with concentrated solar power, we're going to be using mirrors and lenses, kind of like with the solar stove or the solar cookers, except instead of heating up like a small box and heating up food in a pot, this is going to use thousands of mirrors in order to produce extremely high temperatures. And by extremely high, I mean like upwards of 2000 degrees. So with temperatures this high, instead of just using that heat, they actually can use it to boil water, which is going to spin a turbine, and that's going to produce electricity. So even though there's some extra steps here to producing electricity, concentrated solar still has its end product of electricity. So if you have ever made a trip from Los Angeles to Las Vegas, if you made that trip during the day, you might have looked out the car window off the side of the highway and seen these weird sections of the desert that are just like glowing. You just see this like tall tower just covered in light. Well, that is an example of concentrated solar. This is what those look like. So the field of mirrors concentrates all the heat on this tower, and then the tower sends some kind of heated liquid down here where it runs through turbines, makes electricity, and keeps the lights on for us. This is a diagram of what's going on in there. So it's not just lighting up a tower, there's actually pumping liquid all over the place so that that heat can go somewhere else. A lot of these actually don't even use water directly. They get so hot that they're actually melting salt. So, you usually think of salt as a rock. In this case, they're actually melting it and turning it into a liquid. Okay, so we're gonna move on from that to a brief history of solar power. So there's two different things here. So I'm going to be referring to the graphic right here and to the other interesting dates on the left here as well. I'm going to start off at the top. So as far back as the 7th century BC, so that means 2,700 years ago, there's evidence of people using like little magnifying glasses to start fires. So you can imagine back in those ancient times, being able to start a fire whenever you want to is really useful. They didn't exactly have lighters, so being able to use glass to start a fire is a huge benefit. Now, there's a long period of time when we don't really use electricity for much. There is I'm gonna call it a myth of something called the Archimedes death ray. So supposedly in 200 BC, Archimedes, who was this great Greek mathematician and inventor, supposedly he got the idea to have a bunch of soldiers put mirrors on their shields. And when an enemy tried to invade by ocean, they stood on the bay and they all pointed their shields right at the ships. And the mirrors concentrated the power of the sun and set the ships on fire. Now, this might just be a myth, it might just be a story. I don't think it's ever been proven, but it's an interesting story anyway. There isn't really much progress on solar power until the 1700s. This is, so going from 2,700 years ago to only 300 years ago. This is when sailors started to use solar-powered ovens to provide heat on their ships. So you can imagine, again, on a ship, you don't really want to start a fire, so it's a little hard to cook. And that's why it's a good idea to have this alternate source of heat. Between 1700, the next big advance is 1873, when Willoughby Smith discovers that this material called selenium has photoconductive potential. So that's the first step to these, this is the first step to solar photovoltaics, because this is the material that generates some electricity in the sun. And indeed, it's only another 10 years before Fritz produces the first solar cells based on that technology. Now, these solar cells were really bad. They could only produce 1% electricity from the sunlight coming in. So they didn't really catch on until 1954, when instead Bell Labs did the same thing using silicon instead of selenium. Now, in between, we learned a lot more about how light works because Albert Einstein studied this when he published the photoelectric effect. This is one of the works that he won the Nobel Prize for. It really explains like what's going on with light and what happens when it hits an object. Okay, so after the creation of conventional solar panels like we know them in 1954, they start getting used in space as early as 1958. So about as long as we've been able to send things to space, we've been using solar power. In 1973, there's the first totally solar powered building in the world, Solar One, built by the University of Delaware. And very close to that time, President Carter in 1979 installed solar water heaters. So those are just the solar thermal units we talked about on the White House roof. Now, they didn't last a super long time because they only provided hot water. In 2013, I believe, Obama put solar panels back on the White House, but these were the kinds that we normally think about, and they were used to produce electricity instead. All right, engineers, so that was a brief history of solar panels and other types of renewable energy. So don't forget to take your notes and use them to answer the quiz attached to this as best you can. For now, that's the end here. So We'll come back to this with the next assignment, and we'll continue exploring solar power and other renewable sources. But for right now, that's it. Good luck on your quiz, engineers. I'll see you next time.